Alright, so for number 9, they're asking you for the domain, and remember, if there is an x in the denominator, you've got to make sure that this denominator does not equal 0. It could be any number except for 0. So we set it up, x squared minus 7 cannot equal 0. We add 7 to both sides, x squared equals 7. Take the square root, cannot equal. Take the square root, and so then you get x cannot equal plus or minus radical 7. So the domain is any real number except for positive or negative radical 7. You could write it in interval notation, but when it's like this, when it's not equal to a number, I just write x such that x cannot equal plus or minus radical 7. And then the braces. So for number 10, we have another one with a denominator with an x. The numerator has an absolute value of x, so that doesn't really have any restrictions, but the bottom does. So we just say x cannot equal 0. So all x such that x cannot equal 0. And that's it for that one. For number 11, they want you to evaluate this piecewise function for f of negative 4. So you ask yourself, where is negative 4? Is it in this part of the domain, or is it in this part of the domain? Well, we know that negative 4 is less than 1, so it's in this part. So that means that we're going to evaluate using this rule right here. Okay, so we put in negative 4. So f of negative 4 equals negative 4 squared plus 5. So that's 16, positive 16 plus 5. So that's 21. Okay, so another piecewise function for number 12. We're asked to find f of negative 1/2. So again, you ask yourself, where is negative 1/2 in the domain? Is it less than negative 1? Is it between negative 1 and 1? Or is it greater than 1? So negative 1/2 is right here. It's between negative 1 and 1. So the definition we're going to go by is this one. Notice how it has no x. So f of negative 1/2 equals 7. Okay. For number 13, 7, f of 7. Again, where is 7? Is it less than negative 2? Is it between negative 2 and 2? Or is it greater than 2? So 7 is greater than 2. So the definition with the part of the piecewise function we're going to use is this one. So f of 7 equals 7 squared plus 8. So 49 plus 8, which gives you 57. Okay, so a few more domain problems. Number 14, we have find the domain of the function. Notice x is not in a square root function or inside of the radical, and it's also not in a denominator. So the domain for this one is all reals. X could be anything. For number 15, we have an x in the numerator, x minus 4, but it's not inside a square root. So we could, just put it aside and focus on the denominator. Well, first off, x is in the denominator, so it can't be 0, and it's inside a square root, so it can't be negative. So we know that x has to be greater than 0, not equal to, but greater than, because it's in the denominator. We cannot say equal to. So for interval notation, greater than 0 would be 0 to infinity, parentheses on both. Alright, so this one we have both x in the numerator, denominator. In the numerator, notice how it's inside a square root, so we know that x plus 4, x plus 4 has to be greater than or equal to 0. It could be equal up here because it's in the numerator. So we know that x has to be greater than or equal to negative 4. That's for the numerator. In the denominator, the denominator cannot be 0. So 4 plus x cannot be 0. So that means that x cannot equal negative 4. Okay? So even though up here we said greater than or equal to, This one says it can't equal 2, so then we have to combine the two solutions and come up with the final one, which is x is greater than negative 4. This is the answer right here. Okay, so our final answer would be negative 4 to infinity, parentheses, not bracket, because it cannot equal negative 4 because of the denominator. Alright, so the domain of the function f of w, we noticed that there's a w in the numerator, but it's not inside a square root or an even index function radical, so we're okay. W could be anything up here. Down here, w plus 6 cannot equal 0. So w plus 6 cannot equal 0, so then w cannot equal negative 6. So then in this case, my domain, rather than write it in interval notation, I'll just write all w such that w cannot equal negative 6. And that would be the domain. That would be acceptable. In number 18, find the domain. Well, the only thing I have to worry about is that the x is inside a radical right here in a square root. So I have to make sure that x plus 9 is greater than or equal to 0. So x plus 9 greater than or equal to 0. So that means that x has to be greater than or equal to negative 9. So this one I could write in interval notation, negative 9 to infinity, and then bracket on the negative 9. Okay? Number 19, sketch the graph of a function and determine whether it's even, odd, or neither. Well, f of x equals 4, that's the same thing as saying y equals 4, and that's a horizontal line on 4. Oops, 4. So it's a horizontal line. So then, yes, it is even because it's symmetric with respect to the y-axis. Okay, so it's going to be an even function. Number 20 is asking whether it's even, odd, or neither. So this one is another one that is even. Why? Because it's symmetric with respect to the y-axis. That's it. Alright, number 21. Because you notice that for every xy in the graph, there is a matching negative x, negative y. So notice how here I have the point, I mark the point negative 1, 1. Well, here's negative 1, here's positive 1. And then here's positive y, and here's negative y. So for every xy, there's the opposite counterpart. So this function would be odd. It's symmetric with respect to the origin. Alright, so for 22, you have whether the function is even, odd, or neither. You replace all the x's. You could do this algebraically with negative x. And notice here, since we're taking the fourth root of a negative number, it doesn't even exist. So this one's going to be neither. Okay? Because that doesn't even exist when we do that. It's not in the real numbers. For number 23, determine whether, again, same thing, even, odd, or neither. You can replace all the x's. I'll show you that algebraically, how to do that. So 4 negative x cubed minus 5 times negative x plus 6. So this gives you negative 4x cubed plus 5x plus 6. So you compare the original with the new function. Notice opposite, 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 not opposite, because they're exactly the same. So this one's neither. Another way I showed you to look at it was look at the exponents of the x. We have odd, odd, and this one's actually an even because it's x to the 0. So they don't have the same. If they were all odd, it would be odd. If they were all even, it would be even. Okay, but since they're mixed, it's neither. Alright, for number 24, we have in the numerator, this is going to be an even. In the denominator, since notice both of the exponents are odd, it's going to be an odd. And when you have an even over an odd in a rational function, it's actually going to be an odd function. If you graph this, it would be symmetric with respect to the origin.